All right, let's dive into one of the most epic showdowns in science. For centuries, waves explained pretty much we saw with light. You could see the ripple patterns, the colors, even rainbows. Wave theory nailed it. When you shine light through two slits and get that cool interference pattern, that's classic wave behavior. But then, physicists got curious about things on a super tiny scale, and wave theory started to sweat. Enter the, imagine you're shining light on a metal plate. According to wave theory, if you crank up the brightness, you should always knock electrons off, eventually. But that's not what happened. Sometimes, no matter how bright the light, nothing budged, unless you changed the to something more energetic. It was like the electrons were picky about which light they'd respond to. This was a total facepalm for wave theory. If light was just waves, energy should build up smoothly. But it didn't. That's when Einstein, stepped in. He suggested that light comes in little packets called. Instead of a smooth wave, light was more like a shower of tiny energetic bullets, photons. Each photon had a specific energy, depending on the color. Only photons with enough energy could boot electrons off the metal. Suddenly, all those weird results made sense. Wave theory had another moment to shine with the famous double-slit experiment. If you fire single photons, one at a time, through the slits, you'd expect them to act like tiny particles and just make two piles, right? Nope. Even fired solo, the photons created the interference pattern, as if each one went through both slits at once. Wild. So, wave theory wasn't totally wrong. It just wasn't the whole story. Quantum physics showed us that, on the smallest scales, light and matter behave in ways that are both wave-like, particle-like. It's not either or, it's both and. Let's be real, quantum physics didn't just patch up wave theory. It completely changed how we understand the universe. Suddenly, everything was about probabilities, uncertainty, and superposition. The world stopped being predictable and started being, well, quantum. So, next time you hear about something acting like a wave, remember, physics is weird, and that's exactly why it's awesome. Wave theory was great while it lasted, but quantum physics? That's where the real fun begins.